Hi, a very good morning to all of you. As a confirmation, if you can put on the chat that you are able to see me, you're able to hear me, and you're able to see my screen. All the three. Can you please put that confirmation on the chat window, please? And as a part of this particular session, I'm going to probably share all my experience of .NET. It was in the year 2001 when I actually recognized that .NET is going to be the future, and I started teaching .NET with version 1.0 beta edition. That was, I'm talking about way back 2001 January. I still remember January 17th is what when I first took up .NET. And from then it has been a journey. I've seen .NET growing. I've seen how .NET has become adult, how it now has reached almost 22 years, 23 years of journey I've been with .NET. So this particular session, I'm going to share all that experience which I've gone with .NET in this particular journey. So yes, you can be very sure that it's going to be one of the great sessions which you would have probably got an opportunity to hear in all times. Of course, it is going to be more relevant to you if you have some past history in .NET, but even otherwise if you are a absolute new beginner and you want to make your career in .NET programming, this is going to be one of the best introductions you are going to see about .NET. So all this said, we are just going to look at all these topics. Maybe this itself should explain to you how we are going to evolve. In the initial first part, I'm going to just talk about what is current, what is today, what is .NET all about. And then we will see all the implementations. Let it be .NET Framework, Mono, how it has become Xamarin, and then how we have UWP coming into the picture. Eventually, the evolution of .NET Core, the benefits, how .NET Core was adapted in the industry, and eventually how .NET Core became .NET 5, .NET 6, .NET 7, .NET 8, and so on about the journey. So first, what is .NET today? Today it is named as .NET. All that names which we had, .NET Core, .NET Framework, Mono, are history. What we finally have today is .NET. Yes, it is an initiative by .NET Foundation. Now Microsoft has created a neutral body called as .NET Foundation, and through .NET Foundation it has become an open source project. It has become cross platform. That means now it is supported on Windows, now it is supported on Mac, now it is supported on Linux, and also mobile devices like Android, iOS. There also we will find complete support for .NET as on today. So it's a head-on competition to Java. Always .NET had this ability to become platform independent. But the way Microsoft implemented it, their strategy never actually made that possible. If you hear about my sessions on YouTube in 2001, 2002, I've been comparing .NET and Java since then. But never I was able to comfortably say that .NET was platform independent like Java was always platform independent. Java was always implemented on multiple operating systems from the beginning. Microsoft, based on their strategy, did not opt for it. They evolved VC++ way back 90s I am talking about. That's when I started my career. After VC++, or rather side by side, they had Visual Basic. and they had their own legacy on Windows operating system. So when we wanted to use a desktop operating system like Windows, we wanted to build applications for Windows operating system, there was nothing better than Visual Basic. I'm talking about early 90s and even late 90s, 95, 96, 97, 98, 1999. Visual Basic was the king. For every kind of application development, we used to use Visual Basic. Side by side, at that time only, there was internet revolution happening. Internet started becoming cheaper and accessible to common man. So people started now moving to web development. I still remember doing my first web application using ISAPI, Internet Server API, which was developed through VC++, and it was a nightmare to develop a simple hello world application and host it as a web-based application. I had to write huge amount of code. ISAPI was really very complicated. VC++ was overall very complicated for writing applications, had its own problems. C++ was the language, you can imagine. You have to be extraordinary in the pointers. Memory leakages was the major problem at that point of time. Yes, Visual Basic was introduced, but Visual Basic was only for Windows based application. It did have some support for web, but that was literally bare minimum, almost equal to nil. So we used Visual Basic for Windows, extraordinary. For web based application at that point of time, Microsoft came up with ASP, which is Active Server Pages. ASP was simple script, server side script, which we could write in something like VB script. So anybody who had knowledge of VB, what was literally supposed to transit to ASP, because VB script was a subset of Visual Basic. And then ASP was used at the time for building web pages, and it was very simple. We had hardly 6 objects, if I still remember: request, response, server, object, context, and ASP error. I think 5. These 5 objects were supposed to be learned by one, and with these 5 objects we could build entire web page, all dynamic. Of course, dynamic up to the level we could think of in that particular 1999 or 2000 year. Yes, side by side, Java was growing. Java always had the edge because it was initially itself platform independent. People used to write JSP, like we used to write ASP pages in Microsoft technology. We had JSP pages, servlets coming up in Java at the same time. It started with servlets and then they came up with JSP, which was very similar to ASP, and they both were running parallel. But then the revolution happened in 2002, ideally in 2002, but the intention was clear and visible in 2001 that something big is coming by Microsoft. And that's when .NET started in the year 2001. And since then, they have been literally only enhancing .NET with time, adapting to the technology requirements of the industry, to the way the industry has grown, infrastructure facilities have grown. I have seen radical changes in .NET for building applications which are modern, which are current, which are latest today. Today, as I talk to you, I would choose .NET for most of my application development. Let it be Windows, let it be Mac, let it be Linux. It's, I would say, one of the simplest language one can use. Unless you hate Microsoft, I don't see a reason why you shouldn't use .NET for development of application. Think of it, what kind of application you want to develop, and you will be able to develop that using .NET. And it's a huge community support which is provided to us. You have a problem on net, you'll find a solution very quickly. Extraordinary support by .NET support community, and that's where .NET is today. So yes, .NET is free now. It's no more something which we have to pay for. It's cross-platform. Applications can be developed on multiple platforms, including iOS. Open source community. .NET Foundation is the project which provides us complete open source. That means we can take the source of .NET and we can build a layer on top of it in case we intend to. And many kind of applications we can develop. Supported definitely by Microsoft, but also has support from Red Hat, Samsung, many other industry giants are now supporting .NET. So before we move further, what are the types of applications? Just expand your vision about what are the different types of application we can develop using .NET. Basically, it was for Windows operating system. We want to build extraordinary GUI applications. See how in Windows evolved. We had Windows 3.1. I'm talking about before 1995. 1995, Microsoft gave Windows 95. The name itself was Windows 95, and that was a big revolution. Windows 3, 3.1 and Windows 95. Windows 3 and Windows 3.1 were not full-fledged operating system. They were built on top of DOS operating system. So we used to start the machine, we used to get the prompt, and then we used to enter into Windows by using Win. Windows 95 was the straight GUI operating system, and that's when the GUI applications became very popular. And that is when VB6 was used, which eventually in .NET took the form of Windows Forms. Windows Forms was the API, application programming interface, which provided a set of UI controls. When I say UI controls, I mean button, text box, checkbox, label, grid views, list views, tree views, and so many list of ready-made controls which were provided, which I could simply do drag and drop on a canvas so that what I see is what I get. WYSIWYG we call it. What I see is what I get. That kind of UI was developed using Windows Forms. Windows Forms was the most popular API for building GUI applications for quite a long period of time. We used Windows Forms up to Windows XP. Windows XP was the operating system. Then also we were using Windows Forms only. Then Microsoft came up with Windows Vista, which eventually today now is Windows 8, 10, 11 we can call it. Windows 11 today. So with Microsoft Vista, the GUI again took a big change. It became very sophisticated. It became more like gaming. What you see today. Microsoft was not having a UI as in what you see today. Glossy finish, smooth touch on the screen. These things were not there in Windows XP. With Windows Vista, we wanted to develop more sophisticated applications, more gaming-like applications. The look and feel should be very smooth. Suppose I put a ball down, the ball should bounce slowly and then stick to the floor. Or I wanted to give the effect of piano. I can press a key, I can then press a key, and then that piano effect I wanted to build. So these kind of transition effects which I wanted, glossy buttons, my own custom look and feel if I wanted to do, that's when came Windows WPF. This actually came with .NET Framework 3.0, and people started building very beautiful applications with WPF. Eventually WPF further evolved into UWP, Universal Windows Platform. I'll talk more about UWP later. By the time UWP was introduced, we already had multiple devices pretty popular. Multiple devices in the sense mobile, we have desktops, tablets. So we wanted an application which would have a similar look and feel, or at least it should adjust to the screens of the devices. So that's when we used UWP. But UWP was again built specifically for Windows platform only, all compatible Windows. Today, all this is replaced. WPF, UWP is all replaced with MAUI. More about this, I'll talk in the journey. But this is what we would use for developing Windows based applications as on today, so that it is compatible with multiple devices and it is also compatible for multiple operating systems. That's the advantage we get over here. Side by side, when we wanted applications other than Windows desktop, we always had a requirement of Windows services. Windows services are the applications which run in the background of the operating system. They have the advantage that even if you log out of the system, the application could keep running in the background. For example, you start Notepad. When you log out, Notepad will terminate, WordPad will terminate, Paintbrush will terminate. But we want certain applications to continue to run in the background even when we log out. Such applications were developed as Windows services. Windows services also had an advantage that they don't have to use the identity of logged in user. You might have been logged in as user 1, but I wanted to run certain applications with the identity of system user. Some kind of core functionality I wanted to provide. Say simple language, let's say I have something like SQL Server, and I wanted SQL Server to continue to run in the background so that it can consume the request as and when received. Rather, most of the server based applications, most of the daemon applications, always we wanted to run in the background of our system. So on Windows operating system at that point of time, even today for that matter, we have got Windows services. And Windows services earlier, at least I remember doing it in VC++ and that was tough. With .NET, it just became very easy. I could develop Windows services in no time, capture different events of the operating system like operating system started, operating system shut down, user login, user logout, explicit starting of the service, explicit stopping of a service. All these events we were able to capture and write our own custom code with bare minimum effort. So even today we have got Windows services supported by .NET. So .NET is still the best option for developing applications on specifically Windows platform. Microsoft has aligned .NET to the power of Windows. Anything which you want to do on Windows, any kind of customization you want to do on Windows operating system, you will definitely find a built-in support available in the APIs provided by Microsoft. But yes, be very clear, if you are going to develop Windows based application going forward, you use MAUI, not the older ones which were in the past. Definitely this is gone, replaced by WPF, WPF replaced by UWP, UWP replaced by MAUI. Windows services, then came cross-platform requirement. Now, no more Windows is the only king. Sometime I remember 2000 or 1999, Linux came up. Linux operating system came up and that also started providing UI. Prior to that, it was all Unix. Unix was majorly for server side. We used to have server based applications on Linux, on Unix based platforms. But then when Linux came up, it started giving competition to Microsoft. First thing, it was free. From the beginning, Linux is free. It's open source. So people were able to take the Linux based operating system and build on top of it their own custom layers. So it was, now the evolution started where people wanted to develop applications on Linux. So today we have got Linux which has GUI. We have got Macintosh which was always powerful for its GUI. The power of Mac is its GUI. If you talk about any kind of application related to architecting, graphics, animation, nobody can defeat Mac. So people started using Mac for development of applications because Mac applications were also popular. All these things today we can do with .NET. For Mac, for Linux, for Windows, we can build desktop based applications. We can build games using .NET today. .NET had Unity framework. Using Unity framework, we were able to build games. Mobile applications, we have something called as Xamarin. And eventually, of course, Xamarin also is now going to be part of MAUI. MAUI will be centralized. UWP gone, WPF gone, Xamarin gone. The beauty of Xamarin and of course now MAUI is single code base. You write only one project, and with that one single project you will be able to provide applications which can run on Windows, tablets, mobiles, desktop, mobile, tablets, and different operating systems. See the power. So mobile applications very popular using Xamarin all the time till now. Xamarin was evolved from Mono, that history we are going to see. Today we all know how much important is cloud. Microsoft Azure cloud or AWS cloud or GCP cloud or even cloud services provided by others. If we want to build modern applications, modern enterprise applications, applications which should run 24/7, applications which can probably receive requests from entire world, hundreds and thousands of requests per second, then definitely we will have to adapt to the cloud. Cloud provides us huge number of services which makes our life easy. I want to provide search engine service in my application. In no time we will be able to do it. I want to provide security. I would not develop my own security module in the project. I would use some integration with Active Directory or AWS identity management. So some kind of ready-made protocols which we can make use of and implement security in our application. Basically, in short, if I tell you, cloud has made development much easy by providing lot of built-in services. So if you decide to use Microsoft Azure, direct integration is possible with .NET. Of course, Microsoft Azure is not just for .NET. Even Java development can be done, Python development can be done, Go language development can be done, PHP or Python, Go language, PHP, one more. Ruby on Rails can be used. So all this JavaScript, Node.js development can be done. So Azure is multi-platform, no doubt. But definitely Microsoft, everything which we can do in .NET is now getting aligned to the features and supports which are provided by cloud. So if in case we want to build cloud native applications, console applications which can be hosted in cloud as services, serverless applications like Azure Function Apps, those things we can do in cloud. We can build our own web-based applications using ASP.NET Core and web APIs, RESTful web APIs, which are very suitable for microservices based architecture. All these we can do in .NET with ease. Rather, latest versions of .NET are best suited for writing microservices which are very small in size and do a containerization of them. You can build Docker containers and easily deploy them into cloud. But .NET is not away from what is latest happening in the industry. Machine learning, artificial intelligence, and of course the IoT, Internet of Things, where the devices have become intelligent. Devices will start sending signals which can be converted into instructions for the application to perform and take some action. So those things, those APIs are also now available in .NET. So name a type of application. Data science, yes, machine learning, data science libraries now are available in C#. Like people know, they are all available in Python. Definitely Python has become favorite of the people in .NET, but Microsoft has given R language which is equivalent to Python. And if you want to do some kind of complex development, you can make use of C Sharp. But remember, these languages like C Sharp, F Sharp, VB.NET, three popular languages which are supported by .NET today, are modern programming languages. These are object-oriented programming languages. These are languages which can lead to high performance application. There are cases where Python code runs 1,000 times slower than C Sharp. Yeah, in normal cases, 20 to 30 times slower it will be normal, that is. Python is slow. People have accepted that and then started using Python. But otherwise, if you want to do Windows based applications, if you want to be developing high performance applications, there is definitely no substitute to today languages like Java or C Sharp. If you are in Microsoft community, you would definitely want to go for C Sharp, which is simple, powerful. You can achieve almost everything. Type safe, object oriented, and of course retains the expressiveness and elegance of C style. So if you're coming from a C programming background, if you have done C, C++, natural extension of that is C Sharp. But just imagine, though pointers are there in C Sharp, you don't have to rely on pointers in C Sharp. That means with C, C++, the major thing which anybody should do requires pointer knowledge is completely eradicated in the language C Sharp. You don't do memory management at all. You delegate memory management to the underlying framework, underlying runtime, which takes care of things for you. Same thing is with VB.NET. People who were very comfortable with Visual Basic, VB2, VB3, VB4, VB5, VB6, and after VB6 has come VB.NET. So natural extension of VB programmers was in VB.NET for developing Windows based applications. But VB.NET was not just for developing Windows based application, it gave decently good competition to C Sharp. So in the early days, it was simple. If you come from C, C++ background, go to C Sharp. If you come from Visual Basic, then go to VB.NET. Is VB.NET 100% compatible with Visual Basic? No. It was a revolution which happened. So definitely there had to be some changes which the language had to undergo. So that learning curve was always there in Visual Basic to VB.NET transition. At the same time, F Sharp, basically a functional first expression language. When we wanted to build expressions, functionality, that is what is F Sharp, which was used majorly for. Two powerful tools. Even today we have support for all these three. From the beginning, yeah, there was something called as J Sharp. Microsoft came up with J Sharp. The idea behind J Sharp was to bring all Java developer community into .NET. But J Sharp did not click so much, and it got all those people literally eventually merged into C Sharp only. Microsoft started focusing more on C Sharp and then moved away from J Sharp after a while. So there were, if I am not wrong, 60 plus programming languages which Microsoft supported for writing .NET applications initially. Some were by Microsoft directly and some were the support provided by the community. But everybody was working towards making their language compatible to building applications using .NET. Because the way .NET worked at that point of time was, we used to develop intermediate language code. I'll talk about it as we progress further. So we have C Sharp, VB.NET, F Sharp today as the most popular options for developing applications. And then we have got two major platforms through which we can develop applications. No doubt Visual Studio even today is the favorite. Visual Studio 2022 is the current edition. We may very soon look forward to a new edition, maybe 2024 they might come up with a new edition. VS Code took over the industry. one of the best text-based editors, which is lightweight, very lightweight. If you do not have VS Code on your machine, you're outdated. If you do not have VS Code on your machine, you are already outdated. Using VS Code, you can do not only .NET development, you can do Python development, you can do Terraform, you can do any kind of development activity you want to perform, you can easily do it with VS Code. Why? Extensions are available. These extensions are what you have to keep adding based on your requirement, and through these extensions you will be able to develop applications with ease. .NET today is available in the form of CLI, .NET Command Line Interface Tools. So one can just have .NET SDK and can have VS Code. These two things you can have on your machine and you can survive doing .NET completely on your development activities. Everything you can do. But if you want to become productive, rapid application development, if you want to do RAD, rapid application development, if RAD is what is your target, then you should and must go for Visual Studio .NET. Yes, now comes the main story of today. What are the different .NET implementations? It all started with .NET Framework. Then I'm talking about the major. Then came .NET Core. Side by side, there was Mono, which was eventually evolved into Xamarin. .NET Framework introduced in the year 2002, the first version. This is all .NET Framework, all this, and up to 4.8, right from 1.0. I still remember using 1.0 hardly for an year. Had bugs. Literally, people lost hopes also, I would say, because of the way Microsoft in hurry provided .NET 1.0. Very soon, just in less than 1 year, they came up with 1.1, which was pretty stable. 1.1 .NET Framework was replaced by, 1.0 was replaced by 1.1 and it was considered stable. And then we started putting some hopes on .NET at that point of time. It was almost a year. But actual recognition to .NET we got only in 2005. Only after 2005, people started using .NET for real-time application development. Industry did not trust .NET so easily. It had to undergo through that pain and then evolve. So 1.0, 1.1, we used it, did lot of companies. I remember doing corporate training where people were only checking whether it is suitable for them or not. They were doing proof of concepts, but they were not ready to immediately adopt it. But 2005 became a very stable version and it was pretty much accepted, embraced in the industry, and people started developing applications. 3.0 came up with 3 new features: WCF, WPF, and Windows Workflow, along with a tool called as Expression Blend. That Expression Blend was basically used for building WCF applications with ease. WCF was complex. It was not as simple as Windows Forms for development, because we had to use the canvas properly. To make use of the canvas properly, they came up with this tool, Expression Blend. WCF, WPF, and Windows Workflow. There was one more tool called as Card Space, fourth one, that did not click. But these 3, WCF, WPF, and Windows Workflow, were the hit. And all 3 were extensions on top of 2.0. 3.0 did not give any new features. No new features were added to 3.0. just WCF, WPF and 3 point and card space and Windows workflow. These are the only few features which were added to 3.0. Now good thing is, see how did .NET evolve? If I develop an application using .NET 1.0, it required us to install .NET Framework, a special software on our machine for our applications to run. Unless and until .NET Framework is installed, our applications won't work on .NET, on Windows. Applications which were developed using .NET Framework 1.0 were able to work even if you had .NET Framework 1.1. That means 1.1 was compatible with 1.0 or 1.0 was compatible with 1.1. Applications developed using 1.0 we were able to run using 1.1 .NET. Likewise, if you have 2.0, 1.1 applications won't work. You have to separately install .NET Framework 2.0 on the machine. But the beauty was, we were able to do side-by-side installation. We could have .NET Framework 2.0 and we could have .NET Framework 1.1 side by side, and both the applications we were able to run on that machine. Prior to .NET, this was not possible. We had a problem called as DLL hell. I'm talking about before .NET. Anybody who used to write a ready-made class library, anybody who could write a class library was in the form of DLL. I would not call it as class library. I would say simple library, a Windows library. A Windows library was not set of classes at that time. It was mere functions, reusable functions. So if I wanted to reuse my code in multiple applications, I do a library. I build a library. This library I can deploy in Windows operating system, and I have to place it in a location from where it will be loaded by the application. And if I want to load it in multiple applications, I should place it in Windows folder. C:\Windows. There were multiple directories, C:\Windows, C:\System32, and then there were paths and blah blah blah. I don't want to get into a lot of stories. But let's say I should place it in a shared folder like C:\Windows. So from C:\Windows, every application can load the library. Imagine now, I gave a name to a library, demo.dll, wrote some functionality in it, used it for development of my application, which my customer installed on their machine. Side by side, you are developing an application. You also developed demo.dll only, but it was a completely different functionality. And what you did, you used that DLL in your application and you packaged it along with your application. I packaged it along with my application. I deployed my application on my customer's machine. I ensured that during the deployment, this demo.dll was copied into C:\Windows folder. And my application on my customer's machine is working fantastically fine, absolutely no problem. What you did? You sold your application to the same customer. Now he installs your application and your applications start working. My application stops working. Something which was running fine has now stopped working because my application will now load your demo.dll from C:\Windows and it doesn't find the required functionality and it starts crashing. This was one of the major problems in Windows library development, and there was no solution to this problem. And that's why it was referred as DLL hell. People called it as hell. Once you get into it, no solution. There was a dirty solution. I name my DLL as demo sandeep.dll. You call it as demo x.dll. Like that, we ensure that our names are different for the DLL. But what if there are one more Sandeep? Now the world is big. Earlier days, they were not much of internet. So I know if I develop applications in my community, I'll install it. But now the applications can come from anywhere. From any part of the world, I would be able to download and install. This problem of DLL hell was completely eradicated in .NET because it supported side-by-side versioning. There was some concept of strong name which was provided to the library. Now we started calling them as class libraries. The strong name class libraries had name of the DLL. Then there was some GUID which identified the signature of the person who has developed it. And then it also included the version. So if I only develop 1.0, I only develop 2.0, and with that respective application development was performed, my versions 1.0 and 2.0 will work parallel on the client machine. In short, .NET, because of this strong name, started supporting side-by-side versioning. And of course, the same feature was incorporated in .NET Framework also. If somebody developed applications using .NET 1.1 and also using 2.0, both the applications can run parallelly on the same machine. Even if you have 3.0 directly installed, automatically it takes care of installing 2.0. Then came 3.5, which had certain enhancements in the language, which came up with a beautiful feature called as LINQ, Language Integrated Queries. From this point of time, people reduced usage of writing select statement, insert statement, update statement, delete statement. ORMs became popular, object relational mapping. We used to write objects, we used to program objects, we used to make changes to the objects, we used to create objects. Everything we do in object-oriented world, we create our object model, and when we say save this, internally automatically it would convert our objects into, our commands into insert statement, update statement, delete statement, and execute them in the database. A revolution came actually then. I didn't have to write complicated query. If I'm very good at object orientation, I would do object-oriented programming, work with object, and let link providers take care of. There was some concept of link providers. Link providers will take care of converting this object into a format which is understood to the backend. So I would have link provider for SQL Server. I would have link provider for Oracle. I would have link provider for MySQL. So in my front end, I write link. Using the respective provider will take care of my working with SQL Server or Oracle or database, and we become independent of the database. That was one major enhancement which happened in .NET 3.5, and it was a welcome feature. Of course, there were a lot of other features which were added, but link was something which was recognized in .NET 3.5. .NET 3.5, if you install, automatically you would get 2.0 and 3.0. That means applications developed in .NET 3.0, .NET 2.0 also would work with .NET 3.5 installed. Automatically the libraries will take it care of. Then in the year 2010 came up with .NET 4. That's when asynchronous programming came into the picture. One of the major features, multi-threading was concentrated upon. Multi-threading was quite complex in development over here. Now they concentrated on multi-threading, multi-programming. Basically by that time we already had hardware which would start supporting multi-core. Earlier, one processor, one core. That's what Intel always created processors like earlier. prior to 2010. One processor, one core. Now, somewhere in 2009 or 2010, I don't remember the exact timeline, but yes, that is when my Intel started giving multi-core processor. In one physical processor, there will be multiple core. In the sense, side by side, we will be able to execute instructions. If it is a 4-core processor, I would execute 4 instructions side by side. Now, to take the advantage of this 4-core side by side, we have to create multiple threads. Otherwise, we are not going to take any benefit. So, to do that multi-threading, it was complicated, which they really simplified in 4.0. And like this, there is a series of features which they kept on adding from 4 to 4.5 to 4.51, 5.2, 5. Definitely they kept on adding little by little as per the industry requirement. Lot of class libraries were added. Even today, for that matter, we have 4.8, which is not seen support ending. You can use 4.5.2 to 4.8, and even that is supported by Microsoft for your active development. Definitely, side by side, there was evolution of Visual Studio. Visual Studio became more and more easy to use. Side by side, a lot of features were added to make the developer more and more productive, easy to debug, easy to diagnose. Better testing tools capabilities were added to the studio. So with almost every version of .NET framework, they came up with the respective .NET Visual Studio .NET. So yes, .NET framework even today we would probably use if in case we want to build applications which are very specific. Our target is only and only Windows operating system today, tomorrow, day after. Then I don't mind using .NET Framework 4.8, which is decently powerful, pretty fast on building applications for Windows operating system. It can be WPF, it can be Windows Forms, it can be ASP.NET, normal ASP.NET, which can be used for developing web-based applications and web APIs. Before I go to .NET Core, let's talk a little more of how did actually .NET Framework work and how much of this was carried into .NET. See, this is how the evolution happened. Here we had ADO.NET, ASP.NET up to 2.0. 3.0 I told you 4 things: WCF, WPF, workflow, card space. Link and Entity Framework. Forgot about mentioning Entity Framework. Actually, Link was introduced first, and a year later, Link was in 2000. Yeah, Link and Entity Framework. Almost very soon they were added into .NET Framework 2007 only. Link was only for querying. Entity Framework was linking the queries to the backend. I still remember doing something called as link to SQL without Entity Framework. I didn't even use Entity Framework. Straight link to SQL. But then to make that thing independent of the operating system, Entity Framework came into the picture. And today Entity Framework is the most popular thing which we want to use for development of our application. As I told you, 4.0 came up with multi-threading, parallel libraries, task parallel library, parallel link also of course, and now you have got in 4.0 .NET API for UWP applications, .NET API for store. Microsoft created a store actually where our applications can be deployed and installed on desktops, tablets, Microsoft mobile devices, which never clicked of course. Microsoft Windows Mobile was there, it never clicked. They started going with Nokia, and Nokia flopped, Microsoft Windows flopped. We all know today we have only 2 operating systems which are popular. One is Android and the other is iOS. Microsoft Windows Mobile is gone because it went with Nokia and Nokia could not sustain They did not adapt to the change early. Nokia is one such organization which I know which remained adamant. In the year 2000, early 2000, 2003, 2004, Nokia was leader in mobile devices. They used Symbian operating system. But when Google came up with Android, they did not adapt Android. They continued with Symbian and they died. They did not upgrade. Anything which doesn't upgrade will die. Anything which doesn't upgrade will die. That's what I have seen with Nokia and so many other organizations. Don't want to get into it. But task-based async model, all these were introduced in 4.5. So we had .NET API, UWP applications, async, await 4.5, and same things they further improved in 4.6, 4.7, 4.8. Along with new features of C#, it kept on releasing with. Now, how did .NET Framework work? Let us also understand this. Probably most of you already know this, but still I would like to put my experience on this also. It all came up with we writing code in C#, F#, Visual Basic. We write code in these languages. The code of these languages would be compiled with their respective compiler. So I have a C# compiler, I have a F# compiler, I have a Visual Basic compiler. The code compiled by this compiler is common and it comes in a format called as IL, Intermediate Language Code. I write code in C#, the compiler will convert into CIL. It's a separate instruction set which was provided by Microsoft. Definitely that is not machine code instructions. So we used to get as a compiled output of C# .NET EXE or .NET DLL. But what did .NET EXE and DLL contain? Binary format of intermediate language code, not machine code. It was binary form of code which if I want, I can directly write in IL format. So IL was a separate instruction set. Like if I compare it, we have got assembly language, assembly mnemonics. If you come from the engineering background, you have got ADC, MOV, right? These kind of assembly mnemonics are there. If you don't use C language, you can directly write assembly mnemonics and use assemblers for execution of those assembly mnemonics into binary form and execute on a given hardware. Here what are we saying? MSIL code, Microsoft Intermediate Language Code. Initially they called it as MSIL. Today they call it as Common Intermediate Language Code. So MSIL, Microsoft Intermediate Language Code, was the compiled output of all the languages. But the major challenge was there at that point of time. How can one language and other language become compatible? See, the challenge was every language had data types. We had integer, we have byte, we have got long, double. Prior to .NET, every data type was treated differently in memory. For example, Visual Basic had a data type called as variant. Visual Basic, I am talking about legacy. And C++ had void pointers, which are compatible but not same. Integer in C++ probably was 2 bytes, sometimes 4 bytes based on the platform. VB always said integer is 4 bytes only. So this was incompatibility between data types, and because the data types were not compatible, It was not possible to write code in one language and easily invoke it in another language. Definitely, if I write code in C++, a library, I would use that in C++ with ease. But doing it in VB was complicated because types were not compatible. So how will I pass data if I don't have a proper data type? How will I convert it and give it to the library? That was the major challenge. .NET eradicated this problem. They came up with Common Language Specification, CLS. They said, "Oh, whether it is VB, C#, JavaScript, any language, I don't care. You have to be compatible with this specification." So in CLS, they gave specification about various data types. So CLS said integer should be 4 bytes. Now C# doesn't have choice, VB doesn't have choice, C++.NET would not have choice, JavaScript.NET doesn't have choice. All will have to mark their C integer type to 4 bytes only. CLS said there is a data type called as object. All these started supporting object data type. So like this, languages became very similar, not radically different. So whether the code is written in C#, F#, Visual Basic, only the syntax was different, otherwise the grammar is same. That was one thing which was done to ensure that the code of any language can be compiled into common intermediate language code. Another major enhancement which happened at that point of time was base classes, .NET Framework base classes. Now I do programming in Java, C#, VB or C++.NET, JavaScript.NET. Imagine it's like this. I talk Spanish, I talk English, I talk French. Definitely there is no compatibility. A French person will not understand probably Spanish language. But what if all the three are using same dictionary? Imagine. The words in the dictionary are common in all the three languages. Words are same. I call it as water. And let's say in English if it is water, in Spanish and French also it is water only, not something else. Don't you think our vocabulary also will become same? Because most of the vocabulary is through words in the dictionary. .NET Framework base classes is the dictionary of .NET. For development of applications, I would use the classes which would be here, and just that the syntax would be different. Imagine just that the way you would write A, B, C, D is different, but the word is same in every language. That is the kind of architecture which Microsoft adopted to ensure compatibility of source code or compatibility of compiled output of source code in other languages. With ease, we were able to use code compiled in C#, in VB.NET or F# or J# or C++.NET. Like that, language compatibility was provided. We had a common language specification and we had a common set of class libraries which made this whole thing possible. So actually speaking, once the code is compiled, the role of the language is finished. Language is no more important. What is now available is everything in CIL format. Your EXEs, your DLLs are now in CIL format. But are these binaries? Are these machine code? Definitely not. So how will they execute? For me to execute this, again there was a requirement of converting to machine code. Machine code which can go into the instructions of the processor. Hardware processor had got its own instruction set. This code has to be compiled into this format and then executed. And we were able to achieve that only and only using CLR. Common Language Runtime is what one is supposed to make use of. It is through this CLR the code could be compiled from CIL to machine code and eventually executed on the hardware by a given operating system. So we had CLR for Windows. .NET framework gave CLR for Windows only. They did not facilitate CLR after that. That was their problem. So yes, I would write my code in .NET framework in C#, compile that to get into CIL, which had common dictionary, common APIs, we had common language specification, ensure that the code is pretty much compatible with every language, convert into binary form on Windows operating system and execute it. Similar architecture is actually practiced by Java. I write code in Java language, .java files I'll create, compile using Java compiler. We get Java IL code. We call that as byte code. What we called here as CIL, Java called it as byte code. Byte code to run requires JVM, which is similar to CLR. JVM was always available on all the operating systems. Microsoft did not have that intention initially, at least. They did not have CLR on other operating systems supported by themselves. So two major components of .NET framework: CLR, which is an execution engine for execution of the applications. It is at the CLR level, the thread management was taken care of. Programming of multi-threading became a lot simpler. Garbage collection was taken care of by CLR. So you don't have to now do memory management. You don't have to borrow memory. You don't have to release memory. You don't have to worry about type safety because that's taken care by CLS. Exception handling was done at runtime, in the sense the code of F# throws an exception, I can capture in C#. Exceptions became interoperable, which was never the case before that, and many more things which otherwise a developer was supposed to do is now delegated to CLR. Developer life became sukoon, happy. Lot of development was reduced when people started using CLR, .NET in general. And I told you class libraries were provided in such a way that it's like a common dictionary. Anything which you want to do on Windows operating system in generic form was always available. Common functionality was always available. You want to deal with strings, dates, numbers. You want to deal with creating UI on Windows. Everything was available in the class libraries. There were different set of class libraries for different frameworks. .NET framework itself had ASP.NET framework separate. ASP.NET framework was built on top of .NET framework. Windows Forms was a set of libraries built on top of .NET framework. So like that, many layers were added on top of .NET framework, which eased our development in the respective language using these framework libraries. And these are common libraries, whether it is ASP.NET or Windows Forms, we would always use these libraries for development of our application. So this is how .NET was very popular for building applications of different types, majorly focused on Windows platform. But Windows was the not only option. What was the alternative? Side by side, there was Mono.NET, which was getting developed. A person by name Michael de Keyser, he judged it that .NET is going to happen all on multiple platforms. This fellow, with lot of enthusiasm, started putting efforts to make .NET compatible for non-Windows operating system. Mono.NET, or Mono in general they called it, was an open source and free development platform which was very similar to .NET Framework. .NET Framework Mono, side by side, it's not on top of it. What features Microsoft gave in .NET Framework? The open source community, under the guidance of course, the lead, Michael, they started doing Mono. People started building applications using Mono.NET, Mono for non-Windows platforms, which can be Windows applications, which can be even database based applications, libraries, everything we were able to do with Mono.NET side by side. Definitely not a project which was initially supported by Microsoft. Microsoft had their own reasons to only and only support Windows operating system. Their survival in the industry itself was because of Windows and MS Office at that time. But this fellow eventually joined Symbian, the company where he started working, or probably is the founder, I'm not very sure, which later was taken over by Novell, and then it was taken over by Xamarin, and Xamarin eventually had to be taken over by Microsoft. Microsoft purchased Xamarin. It became so popular on non-Windows platform that Microsoft has to literally accept it, and that's when it took the shape of development using .NET on mobile devices. But even before it became Xamarin, Mono was used for developing ASP.NET applications, ADO.NET applications, working with database, Silverlight to build components which would be embedded into web page. If you had chance to hear about .NET, Java applets, dynamic components inside web pages. See, today we see a lot of dynamism in web pages, but that did not come so easily. Originally, it was all simple HTML and vanilla JavaScript. Imagine, bare minimum we were able to do. So any kind of dynamic interaction in the web pages was only possible through Java applets, or at that time Silverlight was used. And of course Windows Forms kind of application also we could develop. Without recompilation we would be able to run it on non-Windows. So the easiest way to describe Mono currently supported is everything in .NET 4. It doesn't support WPF workflow with limited support of WCF, unlimited ASP.NET, async stack, non-async, entire ASP.NET is supported. Also, Mono was used with Unity framework for building games. Games were developed using Unity on Mono platform. Non-Windows games, if you want to develop, we had Mono. So Mono was supported on Linux, Mac, iOS, tvOS, watchOS, Sun Solaris, and blah blah blah. So many operating systems Mono had support. 32-bit, 64-bit, both the operating systems. I would say this was actually a motivation for Microsoft to become what it is today in the form of .NET Core. So if you have a .NET Framework application for Windows, see this beautiful thing. If you have a .NET Framework application for Windows and you want your application to support Windows, Mac, Linux, BSD and bunch of other platforms, but you want to spend minimal amount of effort on converting your .NET applications to run on many platforms, Mono may still be your best bet. Mono is not dead, it's still there. But Microsoft had different plans altogether. They took over Xamarin and they completely focused on iOS and Android. So Xamarin has been there in the industry, majorly used for developing applications, mobile applications on iOS and Android. If you are using besttraining.com application, the mobile app, best.net training mobile app, which we have placed it in Android and iOS, the code base is in Xamarin. Same code base, we just compile it in two different languages, two different runtimes, and get the apps which I can deploy in respective operating system. So when Xamarin applications are compiled, the result is an application package which can be a .app file if it is iOS platform or .apk if it is Android. Source code is same for both of them. Imagine. The compiled outcome is different, definitely, because that is respective platform compatible. The compiled output is different. So at the time of compilation, I should choose iOS or I should choose Android, and these files are indistinguishable from application packages built with the platform IDEs. Android gives its own IDE for development. iOS gives its own IDE for development. But Android IDE cannot be used for iOS and iOS cannot be used for Android. So they had to develop in two different code bases. Xamarin eradicated that problem. One common code base, and we were able to build the application. Ahead of time compilers were used. AOT compiler. That means everything was directly compiled into native format. There is no IL. There is no IL. From C# you can directly get this ahead of time compilation, that is. Compiles Xamarin.iOS application directly into native ARM assembly code. So is the case with Android compiler compiles to IL. Of course, Android has little different story. And then a just-in-time compiler to native assembly when the application launches. There's a JIT compiler, which on demand will compile code from the IL into a native form and caches it, so that next time the same piece of code comes again for execution, the cached copy can be reused. So comparatively it is slower when compared to direct native compilation, but that is significant, very insignificant, very insignificant loss. That's not significant. So Xamarin has been there for quite some time for building iOS and Android applications, and industry has accepted it for a very large time. Side by side, we have UWP. UWP is an implementation of .NET that is for building modern touch enabled. This is important. Now we are talking about mobiles, tablets. Of course, mobile Windows did not click, but still we had tablets, we had desktop, and at times we also wanted IoT devices where the application should run. Internet of Things. It's designed to unify the different types of devices. See, whether it is small to large, varying screen. The UI element responded to the size and DPI of the screen. Same button would look consistent on all the UIs. Button would not get distorted from one UI to another UI if you are jumping. It would be very consistent. So app is running by adjusting their own layout and scale. That was the power. Different UIs targeting PCs, tablets, phablets, phones, and even Xbox, Microsoft gaming device, Xbox, which is pretty popular in the industry for games. UWP applications developed and published into Microsoft Store. So Microsoft created their own store. Like we have got Apple Store, Play Store, and we have got Android Store, Apple iStore and Play Store. Similarly, Microsoft has created a store into which we can put applications and deploy. For example, here also you can just go to Microsoft Store. Using this Microsoft Store, lot of applications which are UWP based applications we can deploy on our desktop. So that store advantage is what they gave to the industry too with UWP, Microsoft Store. Many applications. You can open this and search for many applications and you would find here. Able to use device specific capabilities. If you want, you can use the native device specific capabilities. Adapt the UI to different resolutions and DPIs. So devices, IoT devices, mobile devices, PCs, Xbox, Surface, Microsoft Surface, their own product, HoloLens, all these kind of applications if you want to develop, we had a framework provided called as UWP, purely on Windows. That was the major limitation though. Adaptive user interface, can adjust to different sizes, natural user inputs, you can write through pen, you can give through voice, or you can even click on buttons and mouse. One SDK and tooling. Visual Studio support, extraordinary Visual Studio support. One store, one dev center where applications can be deployed. Integration with cloud services was also provided. So yes, the community moved from WPF into UWP applications for building GUI based applications on different devices. So with all this already there, what was the need for a new framework? That's how .NET Core actually evolved, and let's see this in our next session. How did actually .NET Core evolved? How it became .NET 5? How did version 1.0, 2.0, 3.0, 3.1 and eventually different versions? What is the role of .NET Standard? And how did .NET Standard made code compatible with different implementations? Eventually .NET Framework gone, .NET Core gone, and what we have finally is just .NET 5. Today we stand on .NET 8. So all this journey, what are the features, enhancements which happened, how the language got evolved from version to version, all that we are going to see in our upcoming classes. Important thing is what we are going to learn as a part of this training. This is going to be a full-fledged .NET upgradation course. So I created a new course altogether. What we are doing is this today, and tomorrow it would continue, maybe day after. We will then look at all the development activities which can be done with .NET 8. We'll develop console based applications. We'll develop ASP.NET Core applications. A sample application on MAUI I'm going to show you. Look at new features of C#, 8, C#, 9, C#, 10. But why not C#, 6, 7, 8? Now what I decided is, for the benefit of those who probably take the advantage of joining this particular course, on Best.NET training, we already have the older version of C#. Up to C# 8 I have already, C# 7 I have already covered here. This is deep dive C#. Imagine somebody giving you literally 70 hours of C# subject. This deep dive. So those who enroll for this particular training will also get access to my content on C# from here. Entire source code, entire video kit will be available to you. This whole course. I am going to record the entire series. These are upgrading features. Features from 8 to 9 to 10, maybe 11. By the time I end this, we might see 11 also. Look at ASP.NET Core. Then I'm going to focus more on the new features of ASP.NET Core. What are all new features of ASP.NET Core? How did ASP become ASP.NET Core? How did MVC evolved? Webform gone. We don't use webform anymore. Webform is gone. How did ASP.NET evolved into ASP.NET Core? What are the architectural changes? Those things we are going to work with. Majorly, we are going to work with Web API. In the live training, I will not be focusing on building ASP.NET Core UI based applications. I'll talk about entire ASP.NET Framework architecture, configuration, security, data access, and of course, building web APIs using ASP.NET Core. So as a substitute to handling Razor views, Razor pages, we are going to give to those who enroll for this course access to this particular training. You will get access to ASP.NET Core. This is still the same. I mean, of course, these things got evolved. What is new? I'll put new here, but working with Razor views, HTML helpers, tag helpers, modal binders, validations and data. This is all GUI stuff. This all is not part of live training, but you will get access to this content also. Eventually, what I am teaching live and what is relevant from the earlier version is going to merge into one single course. That is the idea. So you'll have entire ASP.NET new version, latest version. We will see .NET 8 is implemented for this particular training. Yes, if you want to remain latest, I don't think there can be a better opportunity than learning in this particular course with the investment what you are going to make on yourself. You get the entire live training, recorded version also access. During the training, you will get access to C# and you will get access to my ASP.NET Core classes. The same package, whatever is provided by my backend team, in the same cost, all this will be included. This batch, we are going to extend into next, that is working with microservices based application. That's the next target. This is the package actually. This package. So right now I'm doing this. I've already completed Docker and Kubernetes series. If you had any chance to look at my Docker and Kubernetes, they are the best content, I would say, across the world. My Docker and my Kubernetes is one of the best topics. So Docker, Kubernetes, and then now I'm doing this and I'm doing this. So if you want, you can actually take this as a package. You can take this as a package. Right now we are giving it at this price because you will get access to the existing content and the content is getting recorded. This will definitely change. It will increase over a period of time. But right now on this price, you can avail all 4 if you are enrolling for it. Look at this as an option. But if you are also looking at Azure as a package, you want to do Microsoft Azure full kit, and if you want to become an extraordinary developer, both Azure and .NET combination, if you want to do, I would suggest definitely you should look at the gold membership, the package gold membership. You get access to all the content on this website. All these courses you are going to get access to. All the upcoming classes you will get access to for a 1 year period of time. 1 year period of time, you will have access to this entire content. Unrestricted access. So look at gold membership, definitely worth the investment you can make on yourself. And I am telling you, it will change your career. It will accelerate the growth with so many courses in one place. So please read this. You can also avail the EMI options if you don't want to do one-time investment. Break it up, very low cost API, EMI it is very, very low cost. You are not paying a lot of extra fees. So go for this in case you cannot afford to pay down payment. So just one-time processing fee and 6 months or 8 months. Multiply, you will hardly pay little. I think 1,000 or 2,000 rupees extra you might pay. But a worth. In case you are planning to go for entire .NET, microservices, Docker, Kubernetes, that's one option, which is this package. You become a .NET expert. Alternatively, in case you want to do Azure, go for gold membership. As an opportunity, all those who have enrolled for the Azure packages with us. You can talk to the backend team, Kashmira, and see if you want to upgrade to .NET Gold membership today itself, and you get this entire series in that same package, along with a lot of other stuff. AWS is there, data engineering is there, DevOps is there. This itself has huge value. Power BI, entire Microsoft platform. I have recorded this. So yeah, I'm selling literally to you gold membership for your benefit. To be honest, I'm literally pushing you for gold membership. Trust me, you will benefit. You have any kind of questions? I know it's already 9, our time has ended. A lot of people might be getting into work. If you have any kind of questions, any kind of doubts, feel free to call me or WhatsApp me ideally. My number is 98490 01840. Should be there already on the chat also. You can take it from there. And I'm also on LinkedIn. You can see my contact details on chat, my email ID on chat. All those things you will find on the LinkedIn and on the chat. So feel free to connect, remain updated. As usual, don't forget we may continue this session tomorrow. So you will get a invite on YouTube. To get notification, probably you will have to subscribe to the channel and also hit that bell icon so that you get notified when I go live and you can join the session. We may not want to promote tomorrow's session. We just want to see how many come without promotion. So you have to subscribe and hit the bell icon. I'll be glad if you can leave your comments about the session today on the chat. And if possible, share this link. We'll keep it live for a day. Only for one day we'll keep this link live. Today this link will be live. Please feel free to share it with your friends, with your community. Put it on your LinkedIn channel, put it on your Facebook. Let others also take the benefit of this experience. I'm telling you, I don't want to just keep it with me. This is like 27 years of experience which I have, to an extent, I would not say everything, to an extent try to share in this particular class. Definitely it's like making ourselves known to the community. The purpose is very clear. Eventually we want people to start trusting us. People should start looking at the courses and building their career with us. That is the main aim of all these sessions which I am taking. Thank you. See you tomorrow. Bye-bye and take care.